So now we're going to add yet another twist to L'Hopital's rule. We've already seen where we have to apply it multiple times, but what do we do if it doesn't even look like the right form? So looking at this limit, I'm going to go ahead and start with direct substitution. That's always a good idea at first. Okay, so let's see, if I just plug in infinity here, I should get e to the negative 2 times infinity times the square root of 2 times infinity. So let's see, and that's going to be a tiny number, right? This is basically 0, times a huge number, 0 times infinity. I don't really know how to deal with that. Okay, that's kind of one of my indeterminate forms. But notice, it's not one of the 5 indeterminate forms I get to use for L'Hopital's rule. And my original function that I'm trying to take the limit of isn't even a fraction. So as it's written right now, this really does not work for L'Hopital's rule at all. Sometimes we have to be a little bit clever in how we rewrite that original function. So instead of writing it this way, I want to think about how I could write this as a fraction. So essentially, I'm going to leave the square root of 2x, but if I remember how negative exponents work, that's essentially saying put this on the bottom of the fraction. Now it looks like a fraction, and maybe I can get one of those 5 indeterminate forms. So let's try direct substitution again. This is really the same function, just written a different way. So I've got the square root of 2 times infinity over e to the 2 times infinity. So this is infinity over infinity. Now, not only do I have a quotient, I got one of those 5 indeterminate forms that lets me use L'Hopital's rule. So now I can use L'Hopital's rule. I'm going to take the derivative of the top and the bottom. So looking at the top here, I could think of that as 2x to the 1/2 power. So power rule says I've got 1/2 times 2x to the negative 1/2 times, and then a chain rule, 2. And then on the bottom, I've got the derivative of e to the 2x, which is 2e to the 2x. Alright, let's clean that up a little bit before I try to do direct substitution. So let's see, I've got 1/2 times 2 times 2, so that's 2 over the square root of x. And then on the bottom, I've got 2e to the 2x. Okay, so it took some work, but I got there. And now I want to rearrange this even more. I don't like a fraction divided by a fraction. So let's write this as 2 over 2 root x e to the 2x. And in fact, I can even cancel out those 2's. Great. Now I'm ready to try direct substitution. So I'm just going to plug in infinity for x. So I've got 1 over a huge number times a huge number. So that's 1 over a huge number. My answer is going to be 0. Okay, so the trick we learned here is that if your original function is not written as a fraction, we might have to get a little creative with properties of exponents to rewrite it as a fraction so that we can apply L'Hopital's rule.